Now let's talk about magnetic force on a current carrying conductor. Conductor. So previously we have talked about how a force acts on a charged particle if it is moving with velocity v. It was given as qvb, right? Qvb sine theta, or simply q in the bracket v cross b. So this was the situation. The force on a charged particle, moving charged particle, is given by this thing. This was the magnetic force. But how about electric current? What amount of force is there on an electric current? Okay, it must, magnetic field must apply some force on a current also. So let's say electric current is in this direction. Okay, let's take it area as a, this is our conduct having area a. So if the current is in this direction, electrons would be traveling in this direction, right? Opposite to the electric current. Let's say they are traveling with drift velocity vd, because uh, charges in the conductor travels with the drift velocity, right? So they are traveling in this direction with velocity vd. So according to law, the force is given by q in the bracket v cross b. Now here the charged particles are electrons. So we can simply write minus e v cross b. So can we write this velocity this way, x by t? Yes, of course, displacement upon time. Okay, or simply uh, L by t cross b. We have just written x as L. So can we transfer this t to this in this denominator? Yes or no? Of course. Yes, sir. And what is charge per unit time? It is our electric current. So force is given by, on a negative charge particle, it is given by I in the bracket L cross B, or we can say minus ILB sine theta, right? And if the theta is 90 degree, the force on the conductor would be minus ILB. So this would be the answer. Let's take one question and we'll move on. So there is this question. It says that magnetic field is in k cap direction. K cap means in z direction. The figure is somewhat like this way. Okay, this point is A, C, this is B, this is F, D, E. Current is going in this direction. And the question is, find the force acting on the wire, this whole wire. If each section of the wire is of length A, let's say L is the length of each section, okay? Then we need to find out the magnetic force on each of the wires. So now we know that the magnetic force on a current carrying wire is given by I in the bracket L cross B, right? Now magnetic field is in k cap direction. That means if this current is in xy direction, magnetic field would be in z direction, right? Yes. So magnetic field on this AC will be what? It will be simply I L cross B, right? Now what is the direction of AC? It is simply Li cap cross. What is the direction of magnetic field? It is B0 K cap. Yes or no? So if you take this L cross B. Uh, Remember I told you this I cap, J cap, K cap thing, like cyclic rule. So what is I
Yes, sir.
cap cross K cap? It
Minus
is minus J cap.
minus J.
So it will be simply minus ILB J cap. So that means FSE is this much, right? Now what about force on CD section? So let's find out. Force on CD section would be L. Length is in Y direction, right? So it is L J cap cross B is always in K cap direction. So according to cyclic rule, it will give us J cap cross K cap will give us I cap. So it will be simply ILB I cap. Now what is the force on DE portion? So force on DE portion would be I, same as this FAC portion, right? Because they are in same direction. Yes or no? Of course. So
Yes.
FD will be equal to this FAC, this much. It will be also ILBJK. This is the third force. Okay. Now what about this EF portion? So here the current's direction is downward, right? So the force would be
Yes.
equal to CD, but sign would be negative. So F, what is the portion's name? It is EF. EF would be equal to CD, but in opposite direction. What is the CD? It is ILBI cap. So FEF would be minus ILBI cap.
Uh,
This is the fourth section. And the fifth section is FB. So the force would be same as of this section SC, right? Because they are in same
yes.
direction. So FB
Will be minus WL J gap.
would be minus ILB J cap. Now let's find out the net force on this uh, AB wire, and it would be the summation of all these forces, right? So F net would be minus ILB J cap, then plus ILB I cap, then minus ILB J cap, minus ILB I cap, minus ILB J cap. Now cancel out the terms. Okay, so this is ILB I cap plus, this is minus, so they will cancel out each other. So final answer
So
would be
minus and
J cap.
IB and J gap.
That's it. Okay.